Here I've got a Wico Model XH Magneto that a fellow up in Oregon sent to me, so I'm going to go ahead and I'm going to overhaul this for him. Magneto's mounted up in the Magneto tester. I've got it connected here to my first two terminals on my spark gap. I haven't opened it up, I haven't done anything to it yet. I just want to see what the incoming condition of the Magneto is. And we have nothing, no spark at all. Oh, there was one spark. So nothing at all. Okay. Yeah, it's obvious it wasn't working. So let's take it out and let's take the cap off of this and see what it looks like inside. I'm going to go ahead and I'm going to pop the cap off of this. We'll see what that looks like on the inside. Take it off. Looks like, not sure what this is. Looks like at some point someone sprayed some sort of grease or something in here that's kind of, I don't know what that is. Don't typically see that. We can clean those contact points up. One thing that you notice, there's a little bit of corrosion on the top of that point right there. Here's your points right here. On these, you want a 15/1000 of an inch gap in your points. And, oh, there they're opening. I don't see any corrosion on those, so that's good. A little bit of corrosion on your condenser here. That's just on the outside, but if there's corrosion on the outside, I mean that does make you kind of wonder what the condition of the inside of this condenser is. But like I say, we for sure want to clean all the corrosion off of that button right there. Also, it looks like at one point they had, oh, look at that. So at one point they had the, this is your kill switch. At one point the kill switch was connected, but it looks like it has, I don't know, it looks almost like it's been overheated. That would not be good. I can't imagine that any, I think that's just been severed at one point. I'm not sure exactly what it's from, because there's no other heat damage anyplace else in here, and this is plastic. So I think, never mind that. Okay, we'll go ahead and let's check the gap on these points. Let's make sure that the cam of our rotor here is maxed out there on our points, and we want 15/1000 of an inch. So that is way too high. Let's try 22. Here we go. 22/1000. Looks like they are about 22. So we know that the points need to be changed. Now let's go ahead and check what the capacitance of that capacitor is. I've got my multimeter here set to capacitance, and we're going to measure what the capacitance of this condenser is. We should see between 0.16 and 0.20 microfarads. So that's what we're looking for. This is, let's see what this is. So we're touching it there. We can ground out the capacitor to begin with. Okay, so we are up at about 303 nanofarads. So 304. So what it's doing is it's just charging up the capacitor. And so we're at 305 nanofarads. That is 0.30 microfarads. So we are not within spec. So we know we need a new capacitor. Okay, so I just went ahead and I removed the little spring clip that holds the points on. I'm going to slide these up, check the condition of these points. I'm going to remove that little washer, set it down there in my tray. Okay, there's the little washer that's on the back side, kind of like a spacer. And see, there's the points. Actually don't look too bad, but they're very, very, very oily and greasy. So I'm gonna go ahead, I'm gonna throw these in some solvent, get rid of all that grease, and then we can see what the condition of the points are. Okay, now we'll just lift these up off that post, and here's the other side. So you can see they're just very black and they're not really eroded away. I don't see, there might be, if you look right here with the corner of my screwdriver, oops, can't see that, where the corner of my screwdriver is, you might be able to see a slight pit in the points. You want those to be nice and flat so you have good contact between the two, but not nearly as bad as some that I've seen. Like I say, just a little bit oily and greasy. Other than that, the inside of this is pretty clean. Come on. Sometimes they're easy to come out, sometimes they're not. There we go. Okay, so we will for sure need to clean up. There's quite a bit of corrosion here on that bar. Oops, that's my multimeter. So there's quite a bit of corrosion there. We need to clean that off. We need good continuity between the coil and then the base of the magneto. But all in all, that's not too bad. We'll go ahead and we'll check the resistance on the primary and secondary windings of the coil. So I've got my multimeter here set to resistance here, and we're going to go ahead and check the resistance across the primary winding. We want to see it be less than 1.2 ohms. It's pretty low. There you go. You got about 1.2, 1.1 ohms. You want low resistance across your primary winding. And then the resistance across your secondary winding, between this lead and your button here, you want that to be around, 7,000-ish. Anywhere between 6 and 8,000 is usually pretty good. Okay, so this is 6.43 kilo ohms. You see the little K ohm up there in the corner. 6.43 kilo ohms. So that is 6,400 ohms, and so that's good. Went ahead and I picked up a new condenser and a new set of points. I cleaned out, while I was waiting for those, I cleaned out the inside of the case, made sure that there was no dirt down in there. So what I'm going to do is I'm going to clean up this cap, the outside of it. The inside is nice and clean. I cleaned the inside out. There was some residue and stuff in there. That little hole down there in the corner, that drain hole, that was clogged, so I cleaned that out like a bug had built a nest in there. But as you can see, the outside of the, on the inside of these wire terminals, they're really clean. But just the outside of the cap is pretty dingy looking. But what you can do is you can take, this is just a little square of clean Scotch-Brite, and if you just kind of clean that up, it'll smooth everything up. And what I'm going to do is I'm going to go over that and clean off all of the old kind of like sun-baked or oxidized outer coating of this cap. And then I'm going to show you what you can use to make it nice and shiny again. To make it look shiny and nice and clean again is I'm just going to wipe it down with a little bit of this Mop and Glow. So I'm just going to put a little bit of Mop and Glow here onto the rag, and then as I wipe this down, this will soak into that plastic. The plastic is a little bit porous, and it'll soak into that, and it will make it nice and shiny. Before I put the Magneto back together, I'm also just going to clean up the case. There's a little bit of green overspray on there, so I just went and I just removed that green overspray. And it actually was also, had someone in the past had painted it silver, and I just used some acetone from my wife's nail kit, and it removes that old spray paint pretty fast. You can also use carb cleaner, but acetone is cheaper and does a good job. So now we've just got this bare aluminum case, just like it came from the factory. The cap up there. Now we'll just go ahead and reassemble. Now that we've got the Magneto all put back together, we'll just go ahead and set the points. On this, you'll set it to 15 thousandths. You'll also notice right here, down inside there, says set points, 0.015, 15 thousandths. So that's what we're going to do. We're going to go ahead and make sure that this, the lobe of that cam is pushing the points as wide open as they will go. You can see right there. Now that's where you want it. And then we're going to just adjust these down right here until that gap right there is 15 thousandths. So you got a gap of 15 thousandths. Your feeler gauge, there's a little bit of resistance in there. And then now they're closed. Now they are open. Check it. Okay, that's good. Let's throw the rotor back on. Oh yeah, so you'll notice I have not reattached the kill switch right there. I'll do that at the very end, after I verify that the Magneto is working. So there's your rotor. Here is our cap. Oh, there's the gasket. Throw the gasket back on there. We will reuse this gasket because it's not broken. Okay, tighten these screws up right here. Then we'll go throw it on the tester. Got the Magneto mounted up here. I've got it connected to terminals 1 and 2 on my spark gap. I'm going to go ahead and turn it on. You'll hear the impulse clicking, but hopefully we should see a nice blue spark right there and right there. And like I said earlier, you may not be able to see it, but you should for sure be able to hear it. There we go. That's good. Come up closer so you can see it here. Turn off my light. There we go. Hey, there we go. We got a good spark. Fixed. It's fixed. Should be able to put that back on the tractor, and it should run good. So I just got done putting this kill switch on. Like I say, it's just a little thin wire that runs from the back side of the points and the condenser and everything from the back side of that out to ground it out. Now I want to show you. You remember I told you it looked like there was some heat damage to the old kill switch. This is a piece of, this kind of like a strap that used to be connecting that kill switch As you can see, that's definitely been overheated. I mean, it was almost like it was overheated to the point where this melted away, kind of like, oops, kind of like what a fuse would do. And I couldn't understand what was happening, but I think I figured it out. So the gentleman that I got this from said that this came off of a John Deere 50. And I was kind of surprised because typically by the time the John Deere 50 rolled around, you wouldn't see a Magneto on the tractor. You would have seen a distributor. And so I think what just happened probably at some point in the past, someone took the distributor off of that tractor and wired up this Magneto. Now there's a wire on a distributor. There's a terminal just very similar to this one right here. And I'm betting when they connected the Magneto to the tractor, they just thought, oh, I'm going to wire up the kill switch here. And so they did. The problem is that on a distributor, that wire that connects to the terminal on the distributor is actually a powered wire that runs from the battery, and it powers the coil. And so that's the opposite of what you have in a Magneto. A Magneto, this is kind of standalone by itself, and you don't power this. What this does, this kill switch, this grounds out, so it runs to ground, not to power. And so if you were to run power to this, if you were to put this on the tractor and connect what used to go to the distributor and connect it right here, thinking that you were just wiring up the kill switch, what you were actually doing is running 6 or 12 volts into this, which goes with this. If you connected that here, if you connect 12 volts here, I mean, that's running pretty much kind of straight to ground. And so I bet that's what happened when they did that. If that's what happened when they connected the 12 volts or 6 volts, whatever the tractor had, it burned out that link. Don't connect a wire to this unless you know for sure where that wire is going. If it's just running to a ground on the tractor, or like a Magneto kill switch where you pull it out and it just grounds that out, then that's fine. But if it runs to the battery, don't connect it here. Here is a wire connected to the kill switch. So while it's running, I'm just going to ground that out, and the kill switch should work. So it's running right now. I've got it hooked up to this terminal and this terminal on my spark gap. Here's your kill switch. When I do that, it should kill the power here and here. There it goes. Back going. Kill switch. Works great. Okay, this is all done.